Hello dear friends, welcome back to my YouTube channel ChemistryAspirants. Now in today's lecture we are going to learn about the ligands and the types of the ligands. We know that ligands is any atom, ion or molecule which is capable of donating the electron pair to the central metal atom or ion to form the coordination complexes. Actually, the ligand word is obtained from the Latin word which means to tie or to bind. Here you can observe that I have taken the first example as a cyanide ion. Now here in the cyanide ion, this cyanide ion contain the lone pair of electron and hence it is during the coordination formation donate its lone pair of electron to any central metal atom. Now again another example that I have taken, that is ammonia molecule. Now in the ammonia molecule nitrogen contain the lone pair of electron and this lone pair of electron can be donated to the any central metal atom. Hence ammonia molecules also act as a ligand. Now another example that I have taken is here water molecule. Now here in a water molecule the oxygen atom contain the lone pair of electron. It can donate to the any central metal atom and can form a coordination complexes. So all these are the basic examples that we must know. Again we know that in this ligand there is a one particular atom which actually donate the lone pair of electron. Now that atom is called as a donor atom. So now let us know about the donor atom. So donor atom actually donate the lone pair of electron to the central metal atom or the ion. Now again take these three simple example. We know that in this cyanide ion actually the carbon atom contain the lone pair of electron and nitrogen atom also contain the lone pair of electron. So out of that, if the carbon atom donate the lone pair of electron, hence this carbon atom now can be termed as a donor atom, or if the nitrogen atom donate the lone pair of electron, then the nitrogen will be the donor atom. Now second example, that is your simple ammonia. Now here also we know that nitrogen atom contain the lone pair of electron and actually during the coordination formation definitely this nitrogen going to donate the lone pair of electron to the central metal ion. Hence nitrogen in ammonia is actually the donor atom. Okay. Now in the water molecule oxygen atom contain the two lone pair of electron. If the lone pair of electron is donated by the oxygen atom during the coordination formation, then definitely that oxygen will be the donor atom. Now let us know about the types of the ligand. In this video, we are going to discuss the two important factors. The first types of the ligand depends upon the number of donor atoms. And the second factor that we are going to discuss is that the formation of complex molecular structure when they attach to the central metal ion. So now let us start with the first category, that is the classification or the types of the ligand depending upon the number of donor atoms. Generally, the ligands are classified into the three different types, that is the monodentate ligand, or it is also called as an unidentate ligand, then the bidentate ligand, and the last one is a polydentate ligand. Now in the polydentate ligand we are going to consider the tridentate, tetradentate, pentadentate and the hexadentate ligands. Now from your NEET and JEE point of view, these types of the ligands are very important. Here definitely you must remember the examples of all these classes. Now we will going to learn in detail regarding the each type. Let us know about the first, that is the unidentate ligand, or it is also called as a monodentate ligand. Ligand which donate the only one lone pair of electron to the central metal atom or ion through only one donor atom is called as an unidentate ligand. Now if I consider the examples regarding this one, now here the first example, that is cyanide ion, then ammonia, water, then the chloride ion, bromide ion, hydroxyl ion, then the nitro group, then carbon monoxide, and the next one is your pyridine. There are so many different examples that you can cover for your monodentate ligands one. So here you will know that generally only one lone pair of electron is donated to the central metal atom via only one donor atom in these ions or molecules or atom one. Now, let us consider the second class, that is the bidentate ligand. Ligand which donate the two lone pair of electron to the central metal atom or ion through the two donor atoms. Now these type of ligands are called as an bidentate ligands. Now if I consider the example regarding this one, that is your ethylene diamine, a simple bidentate ligand. Here there is a 2 NH2 group which act as a donor atom here, and they can donate the two lone pair of electron to the central metal atom. Now if I consider the second example, that is your oxalate anion. Now here the two oxygen atom which containing the lone pair of electron, the excess lone pair of electron, so it can also act as a bidentate ligand. Now the next example, that is your dimethyl glyoxime. Now here also the two oxygen atom which containing one excess lone pair of electron is also act as a bidentate ligand. So these are the different example that you must remember. Now ligand which donate the more than two electron pair to the central metal atom or ion through more than two or more donor atom. This type of ligand is actually called as a polydentate ligand. Generally these polydentate ligands are tridentate ligand, tetradentate ligand, pentadentate ligand and hexadentate ligand. Now let us know about each one. So first, the tridentate ligand. We know that the tridentate ligands are those ligands which donate the three lone pair of electron to the central metal atom or ion through the three donor atoms. And here if I consider the example regarding this one, diethylene triamine, that is the first example. Now here there is a 3 nitrogen donor atom of a amine group. The second example is your amino acetate anion. Now here again I have shown the structure here. Now in this structure you can observe that there is a 2 oxygen atom and a 1 nitrogen atom which act as a donor atom, and they totally donate the 3 lone pair of electron to the central metal atom or ion. Hence this is the class of your tridentate ligand. Now the next class about your polydentate ligand, that is your tetradentate ligand. We know that these are the ligand which donate the 4 lone pair of electron to the central metal atom or ion through the 4 donor atoms. Now they are actually the tetradentate ligand, and the example is triethylene tetramine. Now here again I have shown the structure. You can easily observe that there is a 4 amine group which donate the lone pair of electron to the central metal atom or the ion, which I have represented by simply M1. Now next class, that is your pentadentate ligand. So obviously the ligand which donate the 5 lone pair of electron to the central metal atom or ion through the 5 donor atoms, these ligands are called as an pentadentate ligand. Now here if I consider the example regarding this one, that is ethylene diamine triacetate anion. So here you can observe in this example the 2 nitrogen atom can act as a donor atom along with the 3 oxygen atom of a 3 acetate group. Hence totally the 5 donor atom which donate the lone pair of electron to the central metal ion. So this is the example of your pentadentate ligand. Now the next class, that is your hexadentate ligand. So 6 lone pair of electron which is donated by the 6 donor atom to the central metal atom or the ion. Now these ligands are called as an hexadentate ligand, and the example is your EDTA, that is ethylene diamine tetraacetate anion. Now here again you can observe in this structure there is a 2 nitrogen atom from your amine group which can donate the lone pair of electron to the central metal atom along with the 4 oxygen atom of the 4 acetate anion. So totally the 6 lone pair of electron donated through the 6 donor atom to the central metal ion. Hence this is the example of your hexadentate ligand. So in this classification we have studied the different types or the classes of these ligands on the basis of the number of donor atoms which is attaching to the central metal ion. So let us consider the second classification or the types of the ligands on the basis of the molecular complex structure when the ligands are attached to the central metal atom or the ions. Now in this classification the ligands are classified into the two types, that is the chelating agent or the chelating ligands, and the second type is your ambidentate ligands. So these are the two different classes. Now let us consider the chelating ligands. Generally these chelating ligands are also called as chelating agents. These are the ligands that are bounded to the same central metal atom or ion, forming a ring-like structure. Now these ligands are actually called as chelating ligands or chelating agents. Generally the bidentate or the polydentate ligand, when they attach to the central metal atom or ion through two or more than two donor atoms, they form a ring-like structure. This resulting molecular complex formation, which is ring-like, is called as chelates. Now here, if we consider the example regarding the chelating ligand, bidentate ligand, that is your ethylene diamine. Ethylene diamine coordinated to the copper, they form a ring-like structure that I have shown here. Hence, this bidentate ethylene diamine can act as a chelating ligands, or it can be act as a chelating agent if it form the ring-like structure. Now the second type of ligand, that is the ambidentate ligand. Ambidentate ligand is that ligand which have two or more donor atom, though during the complex formation only one donor atom is attached to the central metal atom or the ion, is called as an ambidentate ligand. Consider the example here. I have taken the first example of your nitro group. Generally in the nitro group, we know that there is a lone pair of electron that is present on the nitrogen atom as well as one of the oxygen atom. Hence there is a two donor atoms in this nitro group. During the complex formation, if the nitrogen atom donates its lone pair of electron to the central metal ion, it will form a one type of the complex. But in the another complex, instead of nitrogen atom, if the oxygen atom donates its lone pair of electron to the central metal atom or the ion, then it will form the another type of the complex one. So this nitro group generally act as an ambidentate ligand which have the two donor atom, but generally their point of attachment through the different donor atom with the central metal ion or atom one. Now let us consider the second example, that is your cyanide ion. Now in the cyanide ion, generally the carbon and the nitrogen atom contain the lone pair of electron, so both can act as a donor atom here. So during the complex formation, if the carbon donate the lone pair of electron to the central metal atom or the ion, it will form the one type of the complex. Now instead of carbon, if in the another complex the nitrogen atom of your cyanide group donate the lone pair of electron to the central metal atom or the ion, it will form the another type of the complex. So such ligands are actually called as an ambidentate ligand. We have studied the different types of ligands on the basis of the different factors. So thank you so much for watching this video. Hope you will like this video.